The countdown is on, people. You only have to listen to my voice so many more times on one of these videos. Yes, let's do this. Last unit of the whole semester, Unit 11. Today's lesson is called Spaced Figures and Nets, but realize that in this last unit, Unit 11, the whole time we deal with 3D or three-dimensional figures, which we have not done hardly anything with 3D figures yet this whole school year, so now is the time. What I'm going to do is lay out a bunch of different terms when it comes to 3D figures, and then I will show you where these pieces are on a diagram. So the first term is a polyhedron. Now, we've talked about polygons. A polygon is just a figure that has more than 3 sides, but it's 2D. So a polyhedron is a 3D figure where all the surfaces, every side of this figure is a polygon. Okay, and again, maybe we'll remind ourselves, a polygon is just a figure with at least 3 sides. It's a shape, a triangle, a square, a rectangle, an octagon, whatever. So polyhedron is just a 3D figure. Every surface is a polygon. All right, different parts of a polyhedron. So the first term is a face. A face is a surface of the polyhedron, so just like one of the sides. And again, I'm going to show you these things down here on this picture of this box. So it's just a surface of the polyhedron. Again, every surface is just a polygon. Certain shape. Okay, so we've got faces, and then we've got edges. And these terms you have learned before. It doesn't mean I think you remembered them, but you have learned them all before, just an FYI. An edge is a segment formed by the intersection of 2 faces, where 2 faces come together. Then you've got vertices, or just singular. A vertex is a point where 3 or more edges intersect. It's kind of a lot of like overlap with the terms here, but again, seeing like it pointed out on a figure will be super helpful. And then the last one, if you've never heard of what a net is, or if you forget what a net is, so we're just talking like different figures, what are the parts, and then like practicing drawing nets or folding up a net. But a net is just basically like when you take a 3-dimensional figure and you like unfold it and slap it on a piece of paper and make it 2-dimensional, that's called a net. So it's just a 2-dimensional pattern that you can fold up to form a 3D figure. Okay, vocab out of the way. Let me show you these pieces like in real life on this picture right here. So first example, this polyhedron is called a cube. You know a Rubik's Cube. You guys know what a cube is. I feel like I can safely assume that. A cube, every single surface or every single face is what we call it. Every side of this little box is a square when you're talking about a cube. Keep that in mind if you didn't know it. So every single surface, the top, bottom, left, right, whatever, they are all squares. So what we're going to do is identify these different pieces. And what I mean by pieces, I mean like a face, an edge, and a vertice or a vertex. Okay, we need to be able to identify what are those pieces on the box. So let's point this out. Let's use a highlighter here. So this top arrow is pointing to the corner. And I'll annoy you to death with like a Kleenex box, but like each corner of the Kleenex box, that's called a vertex, each little point. And technically the definition of a vertex is where like 3 or more edges come together. So the edges, you guys, are just like the little lines, like where the 2 sides come together. So like this is an edge, this is an edge. See how 3 edges come together to form that little vertex, that little point? So when they point to the second arrow right here, they're pointing to like that right there, that line segment, that's an edge. That's where 2 faces, like the front and the left side, where they come together, that's an edge. And then this last line is just pointing to like this side of the box, that surface. Every surface of your box, front, top, back, whatever, that's called a face. So those are the different pieces of like a three-dimensional figure. Faces, vertices, and edges. You'll see those terms used a lot here. Now let's shift gears and look at nets, which is what we were talking about here. So this is an example of a net of a cube. So maybe this box right here, they just like took this box and they unfolded it and they slapped it down on a piece of paper. The 2D version of your 3D shape, that's a net. So they're saying like, hey, this is the net of a cube. Name the letters that are going to appear on opposite faces. Opposite just means like across from each other. So here's the thing I say every year. Some people are just like, they kill it with this stuff. They have the mind that works for this. They can look at 2D, like this is 2D. Essentially, this is 2D too, you guys. Yeah, it like kind of jumps up out at you as a 3D figure, but like it's sitting on a piece of paper. So it's a 2D figure, the way I'm looking at it right here. Some people have the mind for this. They can just like visualize this three-dimensional shape sitting in front of them, and they're really good at like translating that to paper. Some of us struggle with this. Like our minds just don't like work like this. So whoever you are, you can figure it out. Okay, I've seen so many different types of kids figure this stuff out. So you can do it, but just know that like some people can just get this stuff and like those people are annoying, but like don't compare yourself. But basically, what I have to do is I have to fold this net up like in my mind. I'm not going to physically have the net. I do because I cheated a little bit. But I have to like physically like fold this thing up to make a little cube like this. And I have to think about which letters would be across from each other. So here's my advice. I always start by picking a piece like towards the center. Like don't pick A and F. Those are like on the outskirts of the net. Pick a piece, maybe like D or C, to be the bottom. I'm going to pick C. So I'm going to make C the bottom of this. And what I'm going to do is I'm going to keep C still, and in my mind, I'm going to wrap this net up to be a little cube in my mind. So I'm going to show you, which will make it naturally easier because I have the net, but like I keep C still, and I'm going to bring this flap AB up like this. Okay, then A, this box A, it would like curve around to cover that side. I would do the same thing here. I would flip up this flap, and it would go like that. This might be a terrible demonstration, I don't know. And then like E would come over top to make the top of the cube, and F would fold down like that. So, and maybe you don't need that. Maybe you can just look at this and fold it up in your mind and say, oh yeah, those would be across from each other. But if you can't see it, like E, guys, and C would be across from each other. So I'm going to start there. And they want me to list all the faces that are opposite. So E and C would be across from each other. I will let you look at this tomorrow if you want to. I know sometimes like this doesn't help until you're like actually holding it yourself. Some of us learn that way, like actually holding the thing ourselves. D and B would be opposite of each other. I don't know if you can see that right there. D and B would be across from each other. So that only leaves two other pieces. A and F would be opposite of each other. So a big part of this is going to be exactly that. Being able to like see this two-dimensional thing, fold it up in your mind, and like visualize it as a 3D object. Just takes practice. This is the same kind of deal. This is a net, okay? And they want me to draw the polyhedron. Like they want me to draw the 3D version. So same deal. They want me to fold this thing up and figure out what the 3D shape looks like and then try to draw that, which there's a whole nother element to this. Some of us are not very good at like drawing three-dimensional figures, but I will teach you. I will help you get better at that. So here it is. I made my own. Same thing though. Like I just figure out like, all right, let me pick a piece to be the bottom. We don't know much about like pyramids, prisms, cylinders. Like we haven't gotten there yet. So we're really general so far. You don't have to name this thing. You just have to like try to draw the picture of it. So I'm going to pick that middle box right there to be the bottom. And I'm just going to, in my mind, hopefully you can do this in your mind, I'm going to show you right here. I'm going to fold it up to show you what it would look like if you feel like you struggle with this. Or you feel like you're me just struggling to fold it up. Anyways, this is called a prism. We do prisms next, but here's what it looks like. So the ends of it are triangles and the other faces I can see are rectangles. But you want to try to draw this. This is me awkwardly trying to show you. You want to try to draw this. Here's how I would draw it. I'm going to draw the ends first. So the ends are triangles. And I'm going to draw them like staggered. Like that. And your picture doesn't have to be perfect. As long as like I get the idea of what it should look like, you're okay. And then I connect all the points. I'm going to do this connection dashed. That means like if I was looking at this thing in front of me, I wouldn't be able to see that edge right there, that line, because it'd be like behind the rest of the shape. And honestly, guys, that's a good enough answer. That looks pretty good. That's a triangular prism, but like we'll get there in a different lesson. We're just practicing like drawing and like letting our minds like wrap around this, if you will. Number 4 is going the other way. So I want to take this pyramid, that's a pyramid, and I want to unfold this thing to draw the net. If it's ever a pyramid, and we'll learn more about those as we go, but like the bottom of it is a square. So I start by drawing that. And then like, I don't know if you guys can tell, but like the other faces, like that's a triangle, that's a triangle, that's a triangle. There's 4 triangles here, and they basically just like stem off of every edge of the square. So something like that works. That would be the net for that polyhedron, that 3D figure. That's the biggest part of this lesson, you guys, just being able to do that. We're just trying to get our minds into the 3D like zone here because we need that for Unit 11. But there is one formula, and it's a formula that relates the number of faces, vertices, and edges that a certain polyhedron has. So this formula, it's called Euler's formula. That's the guy who discovered it. You don't have to memorize this, as always, with everything else this year, but it's the faces in a figure plus the vertices always equals the amount of edges plus 2. Feel bad for the guy who figured that out. So it's just these things. So if you take the number of surfaces plus the number of edges, or number of vertices, corners, that always equals the number of edges plus 2. Works in every single polyhedron. So let's practice using it. They say a certain polyhedron has 24 faces, 30 edges. I want to find how many vertices. You're just going to plug in what you know and solve for the missing variable. So 24 faces. I don't know the vertices. Edges are 30. Every single one of you can solve that. Go ahead and do that now. Get the answer in your notes. Example 2 is what we'll end with. This is using Euler's formula, but it's like bumped up a notch. This is a middle school problem. This one is really hard, maybe even like harder than what you might see, but this is high school level Euler's formula. So a polyhedron has twice as many edges as it does vertices. If there are 11 faces, how many edges and vertices does this polyhedron have? So what I want to do here is I want to work with Euler's formula. I know that there's 11 faces, so here's my formula. There's 11 faces. I know that should be plus 2, but I don't know edges and vertices. So if I keep V and E, I can't solve it because there's 2 variables. So that's where I have to come back to this piece of information. There's twice as many edges as there are vertices. So think about how those 2 things are related, edges and vertices. They're not equal. There's twice as many edges. So let's say that and I'm making this up. Let's say that there's 5 vertices. This is how my brain works. If there's 5 vertices, there should be twice as many edges. So there would be 10 edges. So to make these things actually equal, I would have to double the vertices. So another way to write edges is just to say, okay, well, the amount of edges is 2V, twice the vertices. So let me come back here and keep vertices, and instead of writing E, let's write 2V. Now I can solve that for the vertices and find the number of edges.